So we are going to look into Introduction to Organic Chemistry. So I have taught you about this general formula. Okay, the general formula when it comes to alkenes. Okay, so we have this formula CnH2n. If you have alkanes, okay, the one that has carbon single bond with another carbon, we will have the general formula of CnH2n plus 2. If you have alcohol, then the general formula is going to be slightly different, okay, which is going to be CnH2n plus 1, okay, and then OH. So that's going to be the difference over there. Okay, so please remember, okay, for your syllabus, yes, we have a lot, okay, but I want you to focus on these three, which is going to be CnH2n, okay, for alkene, CnH2n plus 2, alkane. Okay, alkene is C double bond C, C single bond C. Okay, and then we have alcohol CnH2n plus 1 OH. Now, always remember, okay, whenever you have double bond, okay, we always refer the double bond to be unsaturated. Okay, and then single bond is always referred as saturated. So this is extra knowledge that I'm actually teaching you. Yeah, so then we have empirical formula. Empirical formula is going to tell us the simplest ratio. So this is the formula that will give you the least detail compared to the others. Okay, you don't have a lot of information about the composition of the molecule. Like for example, a molecular formula, let's say carbohydrate, we have C6H12O6. Okay, the ratio, the exact ratio is going to be 6, 12, and 6. Okay, and if we divide everything by 6, you are going to get with the ratio of 1, 2, and 1. So the empirical formula of the same compound, you can write it as CH2O. And if you look at CH2O, it doesn't actually give you a lot of information. It just tells you the ratio between the carbon and hydrogen. There are two more hydrogen, okay, in ratio compared to carbon, or there is going to be the composition of hydrogen is always double than the atom of oxygen. So it's only telling me that detail. Now you can actually change the empirical formula to molecular formula if you know the MR, okay, relative atomic mass, relative molecular mass. Okay, if you know that, then you can calculate. Okay, and then we also have this structural formula. How to actually write the structural formula? Basically, if you have a molecule like this, a propene, so we just separate them. Okay, carbon and carbon. So I put carbon and carbon, and then I have double bond. So I include the double bond. And then this carbon has two hydrogens, so I put the two hydrogen over here. And this carbon has one hydrogen, so I put the one hydrogen over here. And then this carbon has three hydrogens, so I put CH3 over there. So quite simple. Okay, this is going to be structural formula. And even in your exam, when they ask you draw structural formula, is actually what they mean is just to write the structural formula. Okay, please don't get confused. Now we also have this displayed formula. Now take note, displayed formula will show all the bonds. Okay, so for example, if you have propene, okay, you are going to show all the bonds, okay, that are going to be involved. If let's say I want to actually show the bonds for, like for example, propanol. Okay, propanol is going to be an alcohol which has 3 carbon, prop. Okay, prop is 3. So if I use the general formula, okay, for alcohol, CnH2n plus 1 OH. This is what I taught you just now, the general formula. So if I have C3, I supposed to have double, which is 6 plus 1, 7 OH. Okay, this is going to be the molecular formula of propanol. So how do I draw the displayed formula for propanol? So you always start with the carbon. There are 3 carbons. And then there is OH. Just put the OH over there. You can put the OH anywhere, depends on the naming. So in this case, it's propanol. So let's say we just put OH over here. And then the rest, please remember, okay, there is each carbon, they have 4 bonding. So this one has 2 hydrogen, but this one will have 3 hydrogen because, okay, you need to calculate the total number of bonds. Now, if I write this as my displayed formula, this is going to be wrong. Why? Because you didn't show all the bonds. Okay, so what I need to write? I need to show all the bonds. So I need to also show the bonds between O and H also over there. And then I need to actually put everything. So this is going to be according to the definition. This is going to be what they say displayed formula. So please be very careful, okay, when they ask you to draw the display formula. But here we also learn one more thing. Each atom of oxygen, they have total number of bonds, which is going to be two bonds. Okay, so carbon will have 4 bonds, okay, in total. Oxygen will have in total 2 bonds, and nitrogen, okay, I don't give any example here, but nitrogen will have total of 3 bonds. So maybe you want to actually remember this, very, very important. Okay, now we also have what we call a skeletal formula. Okay, you can use skeletal formula. Skeletal formula, they do give you every information about the composition of the molecule, but the way they are written is going to be like short form. They try to actually put it in a minimal form. They don't write the carbon, they don't write hydrogen, but don't actually take it into your mind that, oh, hydrogen should not be shown at all. Not really. Okay, not really. Okay, because there will be hydrogen later. I'll give you one example. Let me actually show you for propene first. Okay, propene, okay, 3 carbon, okay, and then let's say the double bond is here, okay, and then I want to show propene, so 3 carbon, so 1, 2, 3, okay, zigzag, okay, and then you have, okay, at double bond between carbon 1 and carbon 2. It doesn't matter if you draw the double bond here, it's still the same if you draw the double bond here, it's still the same if you draw the double bond here, it's still the same if you draw the double bond here. Still the same. Okay, still the same. As long it is going to be carbon 1 and 2. Okay, so please take note, you can actually use all this. Now, what happens if I have a situation where I am going to have propan 2-ol? Okay, this is not propanol, this is propan 2-ol. Now, how do I represent propan 2-ol? Okay, so let's actually draw the displayed formula first. Okay, so propan 2-ol. So you have, okay, all this carbon number 1, carbon number 2, OH. Okay, so this is a displayed formula of propan 2-ol. Okay, now if I want to represent this, okay, I will show you one in structural formula, another one is going to be in a skeletal formula. Now, if it is structural formula, very easy. You see it, you separate. Okay, this carbon has 3H, so I put CH3. Okay, CH3. Then I have another carbon. Okay, this carbon is bonded to H and also OH. Bond with H. How to show it is bonded to OH? Because it's a group. Okay, so put a bracket. That OH is going to be bonded to that carbon, and that bracket actually tells me that it is bonded to this carbon. And then you have CH3. This is how you write structural formula. Now, how do you write the or draw the skeletal formula? Very easy also. Okay, you see it. 1, 2, 3. 1, 2, 3. Okay, 3 carbon. And then I know at carbon number 2, there is OH. Okay, now this is carbon number 2. Okay, you can actually put it like this and put OH. This is when I said that not all the time the H will be hidden. Okay, please take note, OH, you cannot hide the H. Okay, you need to actually mention OH. Or there is another way to write. That is also going to be attached to carbon number 2. Now, let me ask you, between A and B, which one looks nicer? Angela? Can I hear you, Angela? Which one looks nicer?
B.
Yeah. So since it looks nicer, they like to actually draw in this form. Okay. So this is actually how you maximize the usage of space to draw the chemical or to draw the skeletal formula. Okay. So you maximize the usage of space. Why? If I actually bring it down, then everything will be too it's going to be how to say, all the information is going to be in one particular place, so they want it to be scattered a bit. Okay, so they actually put it in this form. Okay, so you will see all these kind of things. Okay, how to draw. Okay, so do remember, the point that I want to make it over here is skeletal formula is not a formula where carbon and hydrogen is totally gone. No. Okay, it is can be there to show the functional group. Okay, so in this case, the functional group that you are showing over here for alcohol is called hydroxyl. Yesterday I taught you already, OH is called hydroxyl group. Okay, so this is going to be the functional group. Okay, so let's actually, if you forgot about all the functional groups, I will teach you again. Okay, functional groups for alkene, okay, is going to be carbon-carbon double bond, which is going to be what we call as this compound is going to be unsaturated. Okay, double bond is unsaturated. Why they call it unsaturated? Because if I want to add, I can do addition. The double bond can be broken and new bonds can be formed. Okay, that's why it's called unsaturated. But if it is saturated, then you cannot add. You need to do substitution. Okay, that one we will learn under hydrocarbon. Okay, but the second one is going to be halogenoalkane, and the functional group is going to be halogens. Depends whether they have I, whether they have Cl, whether they have Br. Okay, so halogenoalkane. And then for alcohol, this is what I mentioned to you just now. OH is known as hydroxyl group. Okay, so you don't call them as OH group, it is hydroxyl group. You don't call them as alcohol group, it's going to be hydroxyl group. Okay, now for aldehyde and ketone, this is the part that we learn them together. They are going to share, okay, the same functional group, which is going to be carbonyl group. What is carbonyl group? C double bond O. Okay, C double bond O is considered to be carbonyl group. But the difference between aldehyde and ketone will be, aldehyde will have a carbonyl group. The carbon that is attached to the double bond O will be attached to hydrogen. And this one is going to be carbon attached to the double bond O will be attached to another alkyl group. Okay, and there will be another alkyl group. So I'll just put R1, R2, R1. Okay, so what is alkyl groups? Okay, I already introduced alkyl groups to you. Okay, alkyl groups are basically carbon containing group. Okay, so carbon containing group, they have hydrogen. So for example, CH3, this is going to be methyl. Okay, this is also called alkyl group. Okay, it can be C2H5. This is called ethyl group. Okay, 2 carbon. Okay, so they are going to be alkyl group. We also have C3H. H how many? Let's say you forgot about this. Okay, how to do? Quite simple. If something is attached to, let's say for example, carbon double bond O, and then there is H, and you want to attach to something that has 3 carbon. Okay, you see 1 carbon, 2 carbon, 3 carbon. You see how many bonds that they can form. Each carbon can form 4 bonds. So you draw 4 bonds, you draw. So you count how many hydrogen over there. 1, 2, 3, 4, 5, 6, 7. C3H7. So this is called propyl group, and so on. Butyl, pentyl. Okay. But for you, I told you to remember these two. Okay. Methyl, ethyl. Okay. So this is going to be alkyl group. Okay. Alkyl group. Now, do not confuse alkyl group with arenes. Okay. Arenes are compound that has, okay, the simplest arene is going to be, I think generally, this is going to be arene, C6H6. It's going to be arene. Okay. But now let's focus on the straight chain. Okay. Straight chain. This one you will learn arenes in A2. Now, straight chain, okay, it's going to be a very simple term. So in your chemistry, we don't actually say straight chain. We call them as what we call is going to be aliphatic. Okay, aliphatic compound. Aliphatic compound, why there is term? So basically, it's just a straight chain, okay, with branches. Okay, so aliphatic compound. And what is going to be aromatic compound? Aromatic compound is the one that I mentioned to you. The moment you can see a benzene, something, a structure like this, okay, this is called arenes. And they are going to be aromatic. Why aromatic? You know, benzene, your car petrol, okay, when you go and smell the car petrol, it has this some kind of smell. That smell, for some people, it's nice. For some people, it's bad. Okay, but generally, that smell is called aromatic smell because it contains a lot of this compound. Okay, so that's why they are called aromatic. Okay, aromatic, it gives you a very special kind of smell. Okay, so your benzene, your not the benzene in chemistry. Okay, when in your Indonesian, you are the only country that calls petrol as benzene. Okay, let me check whether the screen is frozen. Let me check. Can you guys still hear me, Jordan? Okay, Jordan, can you still hear me?
I can hear you now, sir. Just
Yeah,
now
I
talk to
think
you.
it was actually disconnected for a while. Anyway, okay, I wanted to say this, okay, because only in Indonesia you call petrol as benzene, okay, and benzene, the one that you use is this term, benzene, okay. So the benzene that I'm using is going to be benzene. This is totally different. Okay, I do not know why this term came, maybe probably from this. Okay, but benzene is just a small part of it. Okay, so in generally in other countries we call the that as petrol. Okay, so petrol generally are going to be something that has aromatic smell. Okay, aromatic smell. So I think I covered that part. Okay, let me actually move on. Okay, so here you can see I have actually mentioned about aldehyde and ketone, and then I mentioned about the R1, R2, alkyl groups, and so on. Now, let me actually enter the carboxylic acid. Okay, carboxylic acid, the functional group is going to be carboxyl group. It's going to be different than carbonyl. What is carboxyl group? Okay, this is carboxyl group. This entire C double bond O and OH is called carboxyl group. You cannot actually ask, Mr. Gopi, are they carbonyl and hydroxyl group joined together? No. They are basically, because they are carbonyl and then hydroxyl, it's a special name because they exist together. So that's why it's carbonyl with hydroxyl. So they name it as carboxyl group. Okay, so it's going to be something together. Okay, but they cannot exist like when they are existing with carbonyl alone, then it's going to be aldehyde and ketone. Okay, so the way they react, the chemical properties are totally different. Okay, carboxylic as like generally carboxylic acid, you know, ethanoic acid, propanoic acid, okay, all this. So what is going to be attached over here? Again, another R group. What is R group? They are alkyl groups. Okay, so methyl, pentyl, butyl, and so on. Okay, so you have all that. Okay, And then ester. Okay, ester is going to be different as well. Okay, the ester is going to be C double bond O. There is O. Okay, unlike like carboxylic acid, which is supposed to have H, they are going to be bonded to another R. Okay, that H is not there. So this is going to be R1, this is going to be R2. Okay, I told you not to overthink this. Okay, we will learn about this in future. Yeah, amine. Okay, the amine, we call it amine group also. Amine group. So anything that has R and then N and then H2. And here you can see if I represent this R, N, H, and H is the same thing. You can see that nitrogen has total of 3 bonds, like what I said just now. Yeah. And then you have also what we call as nitrile. Okay, nitrile is going to be anything that has this. Okay, so you can see each carbon will have 4 bonds. Each nitrogen, on the other hand, has 3 bonds. Okay, but if you have CN, they are called nitrile. Okay, so this is going to be nitrile. Amide. Okay, amide is like similar to amine. Okay, but what is going to be the difference? You are going to have C double bond O, and this one is going to be NH2. So this is going to be R. So they are going to be having a different properties as well. Yeah. So all this, okay, I have listed down for 10. I think in your textbook they mentioned about until 9. Why I listed down until 10? Because all these 10 will be the one that you will learn for your JC1 and JC2, and also more. Okay, also more related to the benzene. You will learn more. Okay, but by the time you complete, you will actually know all this. Yeah. So the next part, okay, the one that I taught you also, okay, the naming part, okay, which is going to be, if you have number 1, okay, then it's met. Okay, I want you to memorize now itself. There is no tomorrow, there is no later, okay, there is no next week, there is no the following month. Okay, you memorize now itself. Okay, number 1 is met. Okay, number 2 is going to be at. Number 3 is prop. Number 4 is boot. Number 5 is pent. Number 6 is hex. I don't care about this. If you want to memorize on your own, up to you. Okay. But I want you to memorize the first 6. Okay. You must know. Met is 1. Okay. At is 2. Prop is 3. Boot is going to be 4. Pent is 5. Hex is going to be 6. I think pent, no problem. Pentagon, okay, 5. Hexagon, 6, no problem. So the thing that you need to memorize is only 4, okay, nothing, not a lot, okay. Met, okay. Methane, I think you already know methane is 1 carbon, okay. At, I think you would have actually know after ethane, after methane, there's always ethane. So 2 carbon. The only thing most probably you need to remember is going to be 3 and 4, prop and boot. Okay, don't tell me you cannot remember that. Okay, this is very, very important. Okay, please remember this. Okay, so now the branching. Okay, this one is what I told you, the alkyl groups. Okay, the branch. The branch can be in methyl form, CH3. It can be in C2H5 form, which is ethyl group. And today also, earlier I mentioned about propyl group. Okay, propyl can be C3H7. I already mentioned to you how did I came up with that 7. And it can go on. Okay, it can go on. Predict what is going to be C4. I can actually just go on like this. H9. How? Every single time when it goes here, you can see there is an increase of CH2. I'll leave it next time. Yeah, this is what we call homologous series. Okay, it means that if you have, okay, if you have like alkane, the entire alkane, the difference of them, like for example methane, okay, you see CH4, and then I have C2H double plus 2 is 4 plus 2, which is going to be 6, and then C3, okay, double is going to be 6 plus 2 is going to be 8. You see what is the difference between them. There is going to be increase of C, and then H is going to increase by 2. There is going to be increase of C, H is going to increase by 2. You can see that every single time as you go on, there is an increase of CH2. So it means that if you look at alkane, alkane is considered to be a homologous group. Okay, it means that they belong to the same group. Okay, what is homologous? Basically, just imagine they are in the same class. Okay, so they are always going to follow that trend. Okay, so something like that. Okay, so if you have alkene, they also follow the same trend, CH2. Okay, so you can actually refer to that. Okay, but let's actually move on. Naming of organic compound. Okay, for naming, I taught you about this. Okay, how to name. First, identify functional group. Second, identify longest carbon chain. Identify branch or parts. Okay, I will add additional thing. Position of the branch, or the position of the part, or position of alkyl group. Okay, so if you look over there, F, L, O, okay, then P. Okay, so I just put it as flop. Okay, if you want to remember. So apply flop. Okay, how to apply flop in all this? Naming organic compound. So first, find the functional group. The functional group over here is going to be all single bond. So it's going to be alkane. Okay, and then longest carbon chain. I know this is going to be my longest carbon chain. So it's going to be 4. Okay, but is 4. So you just follow AN. So ANE, butane. Okay, and then P, flop. Yeah, P, the parts. Okay, or the position. Okay, so the part that I have over here is going to be your methyl group. It's a group, it's a branch. Okay, and this methyl group is attached to carbon number 2. So I need to put the position over there. So it's 2 methyl. Okay, 2 methyl, and then butane. You take note where I put this sign over there. Okay, and there is no sign here. Okay, please take note. Okay, so if I want to actually apply the same method for flop over here, identify the longest carbon chain. Okay, but again, before that, for both of them, I already identified the functional group. They are all alkanes. Okay, and you can see if I want to identify the longest carbon chain, okay, 4. If I want to identify the longest carbon chain, it's not 4, yeah. Okay, it's not 4 like this. Okay, please take note. It's going to be 5. Okay, so this one is going to be but. This is going to be 5 pent. Then alkane, so ANE. Then you need to put the P, flop. Okay, so P, position and the parts. Okay, each of this carbon is going to be your branch, CH3. So methyl. Okay, I have 2 methyl at position what? 1, 2, 3. At position 2 and 3. So how do I write? 2, 3. Put this. And then I want to tell there are 2 methyls. Dimethyl. And then join together butane. Very, very simple. Okay, no need to make it very difficult. You can see over here pentane. Okay, but now I have CH3 here. I have CH3 over here. So I need to give the number for the carbon. 1, 2, 3. Why, Mr. Gopi, I cannot actually give the number from here? 1, 2, 3, 4, 5. You can give number. Okay, but you see, we need to select the smallest number. If I select over here 1, 2, 3, I will have 3 and then 4. If I follow from here 1, 2, 3, I am going to have the combination 2 and 3. Which one is smaller? 2 and 3, not 3 and 4. So I will actually select, okay, 2, 3, and then there is 2 methyl, so dimethyl, straight away pentane. Okay, I hope, Kenneth, you can understand this. Okay, this is the second session. Okay, so please actually try to remember this, and I will upload this video. You listen to this video until you can understand. Okay, so I'm going very, very slow, very, very clear over here. Now, how to name? Okay, I already told you. Just use flop. Okay, now if let's say I have something like this. Okay, so first, if you use flop, okay, the functional group is going to be the OH. So the functional group is hydroxyl group. So how do I name hydroxyl group? So it's alcohol. So it means they will end with ol. Okay. So you look at the flop. Okay, functional group is done. Longest carbon chain. Longest carbon chain 4. So it's going to be but. So if I have but, and then I'm going to actually have alcohol, and that position of the OH can be in different position. But in this case, you need to mention where the OH is coming. So you see 1, 2, 3, and 4. So the position is going to be at carbon number 2. Of course, I can actually put it as 1, 2, 3, 4 like this. But that's going to be carbon number 3. I don't want. I want something that is going to be smaller. Okay, so this is going to be position number 2. So I know the OH is going to be, or the all group, okay, the all or the hydroxyl group is going to be at position number 2. So how do I name this? So this is butanol, but I need to actually name butan, okay, and then at position number 2, you put 2 and then all. So it's basically a butanol, but it's a different kind of butanol. Okay, because I'm actually telling it very clearly that the alcohol group is at position number 2. Now, what happens, okay, if I have something like this and the OH comes over here? This is going to be different because the naming is going to be different because it's going to be butanol, okay, but okay, this is going to be carbon number 1, not carbon number 4, carbon number 1. So this is going to be butan 1 all. Okay, so that is going to be the one that you need to actually take note, okay, which is going to be butan 1 all. Now, so you need to also look, okay, over here, you need to mention about, okay, so I want to use flop over here. Again, the functional group is going to be alcohol. Okay, so the next thing is going to be, I know this is alcohol, and then the next thing is going to be the longest carbon chain. So I can see the longest carbon chain is going to be 4. So I know it's going to be something to do with butanol. Okay, but okay, I need to actually now make sure which carbon is the all. So 1, 2. Okay, I can actually make sure it's going to be at position number 2, not at position number 3. So identify the functional group first, not the branch. Okay, please take note. Okay, functional group. Okay, so now it is going to be position number 2. So it's going to be butan to all. The last thing that you need to take note is going to be the alkyl group or the branch. Okay, the branch is going to be at position number what? Now, this is not the moment you actually say 1, 2, this is automatically 3. You cannot actually suddenly do backtracking saying that now I want to count from 1 and 2. No, the moment you already identify that this is 2, this is automatically, like it or not, will become number 3. Okay, so this is going to be 3-methyl. Okay, 3-methyl butan 2-ol. This is how you name. Okay. Next.
Sir, instead, can you make the all become 3 and the metal become 2?
Cannot. Cannot. Why? Because that's why I told you the priority is given to the functional group. Okay. Priority is always the functional group. The branch comes later. If you are drawing a tree, draw the tree first and then think about the branches later. So this is actually the way that you want to remember. If you want to mention about functional group, the moment you give number, you must give the lowest number to the functional group first. Okay, so even though they are side over here, what is the priority? The priority is your functional group. It applies not only for alcohol, it applies for your alkene as well. Okay, I'll give you one example for alkene here before we continue. So let's say, for example, I have C like this, okay, and then I have double bond here, and then I have CH3 here. Okay, let's say now I want to actually name this. Okay, so according to flop, okay, I have identified that it's going to be a double bond, so it's going to be alkene. My priority is going to be my double bond. Okay, my priority is going to be double bond. So then the longest carbon chain is going to be 4, so it's but. Okay, but. So now for alkene, is going to be slightly different when we give numbering. Because why? Because the double bond is going to be between two carbons. Okay, so you cannot say this is 1, this is 2. No, you don't actually say that. Only for alkene, you are going to number it according to the space or according to the dash or the line. So how do I number? This is 1. Okay, this is 1. This is going to be 2. This is going to be number 3. So that is going to be 1. Okay, that is going to be 1. If that is 1, automatically the one on the left will become your carbon number 1. I want you to remember this. Okay, automatically that is going to be carbon number 1. So it means this is put 1 in. Okay, put 1 in. Now, since that is going to be, this carbon is automatically carbon number 1. This is automatically carbon number 2, automatically carbon number 3. So when I represent the branch for methyl, the methyl we are going to actually use 3 methyl. This is the same as I mentioned to you for the alcohol. Okay, it means that priority is always given to the functional group, then the last you add in. Okay, now next, okay, I have so many examples over here. Okay, but I will just show you, okay, how to name only. Yeah, so this one, the functional group. Okay, if you remember, this is going to be aldehyde. Okay, so aldehyde, okay, how to name? Okay, it will have Al at the end. Okay, so this one is going to be 3 carbon, so it's going to be known as propanol. Okay, propanol. Okay, and then this one, okay, you can see that, okay, this is going to be also known as aldehyde. Okay, you can see here. So if this is aldehyde, okay, you can see the longest carbon chain is going to be this one. So this is butanol. Okay, there is no need to say carbon number 1, because automatically this is going to be carbon number 1 because the functional group is at that carbon. So if I want to refer to this CH3, is going to be 1, 2, 3. So the methyl is at position number 3. Okay, we will learn more about this. Okay, so I'm just giving you one example. Yeah. So the next one, like for example, this one is what we call as ketone. So how do I write down for ketone? Okay, 3 carbon. So prop. So this is known as propanol. Okay, propanol. So, and here you can see, okay, if this one, the longest carbon chain is going to be like this. Okay, so the double bond O, okay, for this one propanol, the double bond O cannot come here, cannot come over here, because if it does, then it will become aldehyde. Okay, no need to think a lot. But for this one, the double bond can come here, can come different places. Okay, so the numbering is important. Okay, so this is going to be pent, okay, pentanon, okay, but okay, this numbering is important at position number 2. So pentan 2 on, okay, this is going to be pentan 2 on. So this is 2, 3, 4. So this is 4 methyl. Okay, I'm just showing you, okay, the same concept. Okay, the rest, okay, I think you get the idea. Okay, basically this is going to be carboxylic acid group. So this one is going to be a straight 4, so it's going to be known as butanoic acid. No need to give name because that is automatically carbon number 1. Okay, butanoic acid. So if you look over here, now you need to give numbering. Why? Because it's butanoic acid. Okay, but this is automatically 1. So this carbon is automatically carbon number 2. So this is going to be 2 methyl. Okay, 2 methyl butanoic acid. Quite simple. Okay, don't actually take it as 1, 2, 3, 3 methyl. No. Okay, we follow from the functional group. The rest, okay, I think you get the idea. Okay, I think no need to actually mention all this. Okay, you can actually get it. Like for example, this is known as methylamine. Okay, this is propylamine. Okay, and then this one, okay, is going to be propanitrile. Okay, this is Nitrile. Okay, you can actually see from your textbook. Okay, not so important. Okay, naming of ester also we learn later. Not only naming of ester, most of it. Okay, all this we are going to learn later. This is just an introduction. Okay, now here, this one I told you to watch the 3 videos and then do a Jamboard discussion to summarize. Actually, I changed it already, so no need to do the Jamboard discussion. So you are going to actually summarize, okay, or do a reflection on it, okay, and include it in your Google site. I have given you 3, okay, because we have done this in your atomic structure, okay, and that's why here now they actually are referring back to sigma bond and pi bonds, okay. So for sigma bond and pi bond, generally if you have, okay, uh, something like this, they can actually ask you, okay, how many sigma bonds are there in this particular carbon. So there are total 4 sigma you need to know. Let's say, for example, if I have like this, okay, and then they ask you how many sigma bond and how many pi bonds are there. So you need to know 1, 2, 3, 4, 5, 5 sigma, and one of it is going to be 1 pi. Okay, all this you have learned earlier. Okay, so you need to know how to use them. Okay, so and then you also need to know about hybridization. If you don't understand, then refer to the video. Okay, there are 4, so it's supposed to be sp3 hybridized. If I ask you what is going to be the hybridization over here, that's 1, 2, 3. So sp2 hybridization. Not clear, forgot, refer to the video. Okay, it's been done already. Okay, 3 videos are there. Okay, so you can actually go through that. Okay, put it in your Google site and get it done. Now, what we are going to do now, okay, I give you, okay, 3 minutes, okay, to review, okay, what I taught you. Okay, refer to your textbook, okay, review. We will actually have a quiz now. Okay, it means it's going to be a simple quiz based on my discussion today. What I told you to remember, I'm going to ask. Okay, refer to your textbook, 2 minutes, then we will start. Any questions, you can ask me.
Sir.
Yeah.
So we need to remember all